Okay. All right. Well, welcome to Devoxx France. I hope you're all as excited to be here as I am. I've been a fan of the Devoxx conference in Belgium for quite a while, so I'm very glad to see a conference here. I can't tell you, exactly how the conference will be because this is the first time, but I'm sure it's going to be every bit as excellent as the one in Belgium. So, welcome. As you can see, this session is called JavaServer Faces, Antipatterns, and Best Practices. So hopefully you're in the right place. We've got about 3 hours. These slides probably will take 1.5 to 2 hours or so. So what we'll probably do, what I'd like to do, but it's not a very large crowd, we can make this a little bit informal. So if you have questions along the way, let me know. And then if we get to the end and we have more time, we can open it up to general Q&A about any issues you're having with JSF or other sort of anti-patterns you've had, et cetera, et cetera. Okay? All right, so it's a little bit about myself. My name is Kito Mann, and, oh good. Looks like the battery's dead, but it's not. My name is Kito Mann, and I'm the principal consultant at a company that I run called Virtua, and we do primarily training, consulting, mentoring, and architecture for shops working with JSF and Java EE and those sort of related technologies. We also work with clients using LifeRay Portal as well. So those are sort of the areas we specialize in. I also work with JSF component vendors. So sometimes I help them with product strategy. Sometimes I also do consulting and training for them as well. I'm also the author of a book called JavaServer Faces in Action. Has anyone heard of this book before? I'm just curious. Ah, wow, a few of you have heard of it. Okay. So this is one of the first JSF books. It's very old. It's out of print. I never came out with a second edition. But it was one of the first JSF books, and I thought it was pretty good at the time. So that's kind of how I got into JSF to begin with, was I wrote that book several years ago. I also run a website called jsfcentral.com, which is a good place to go to find resources about JSF. Primarily now, it's probably better for finding new content. So we've always got podcasts and articles about different JSF topics. So, for instance, we just had an article about rich faces come out. We just put out a podcast with an interview with Werner Puntz, who's one of the My Faces committers, about the extension scripting project, which is another part of My Faces. And we also have another podcast series that's sort of every month or two, me and a couple other guys talk about different JSF and Java EE topics, mostly news-oriented. And that's called the JSF and Java EE Newscast. So you can find all that stuff at jsfcentral.com. And also, I speak at lots of conferences, and I'm a member of a few expert groups, including JSF and Portlet. Okay. So that's pretty much my story. I want to get an idea from the audience. How many of you guys are currently working with JSF? Okay, so there's like a handful of you who are not. Okay. For those of you who are not currently working with it, have you like read about it or have some experience with it? Okay, kind of. All right. So for those of you who aren't too familiar with JSF, if I mention something and you really have no clue, just raise your hand and I'll try to explain it. Okay. Most of this talk will be geared for people that have really been using it more on an everyday basis. For those of you who are using JSF, how many of you are using JSF 1.2? Okay. How many of you are using JSF 1.1? Is it WebSphere you're using? Are you using WebSphere? Okay. Most people using JSF 1.1 are using WebSphere, so I'm sorry. How many people are using JSF 2? Okay. And how many people are using JSF 2.1? Ah, all right. So we've got some trailblazers here. Okay, cool. Oh, okay, cool. Wi-Fi person, that's a good thing. All right, so we're all application developers, right? And when we build applications, we really would like it if our applications look kind of like this, right? You know, everything's, looks very pretty, pristine. You've got a beautiful skyline. It looks like, a real city, right? So this is what we'd like to build. And this is what, those of us who are really into the craft or who are really into, good design and things like that, this is what we try to do, right? Unfortunately, a lot of times what happens is we end up with something that looks a little bit more like this. All right, so how many of you feel like sometimes your applications look like this, no matter how hard you try? Anybody? Okay. This is often how it looks when I am on a consulting project. Okay. So really what you want to do, you want to spend as much time as you can trying to make your application look like this instead of like this, because this is a lot harder to maintain, right? And it doesn't look as pretty, of course. Now, it might look okay on the outside. So sometimes you have an application that looks like this on the outside, right? But on the inside, it looks like this. But, at the end of the day, you want to put in as much effort as you can, or basically as little effort as you can to make your application look like this. Like this. Okay? So what we're going to talk about today are ways you can make it look more like this and also make it easier to maintain, because an application that actually is, attractive and well organized is easy to maintain. There's sewer systems, there's electricity infrastructure, all those sorts of things, which in a town like this isn't really around, right? So, number one thing to do is avoid the big ball of mud. Okay. So if you look up this URL, you'll find a long rambling description about what the big ball of mud is, but essentially, it's a lot of code piled up that, presumably work to some degree, but, there's not really much structure or design or anything, okay? And even though frameworks like JSF sort of push you towards some sort of a design, you can still make a really big ball of mud, okay? So the bulk of this talk is going to be anti-patterns, right? So these are the patterns that I've seen over the years in consulting. And a lot of them really, they stress me out. I'll go to a new gig, and I'll look at the code, and I'll see a lot of this stuff, and I just think, wow. A lot of it, sometimes it's basically, sometimes it's, just junior programmers get thrown at a problem. How many people have seen that before? You have a whole bunch of junior programmers that build something. It doesn't look so hot, right? That happens. Sometimes it's just ignorance about JSF, okay? So, JSF does a lot of different things, and probably one of the biggest issues with it is that there's often many ways to do things, right? So a lot of times developers build things without really understanding how JSF works, and sometimes that works against JSF. So that's something I also see. And then I also just see bad coding, right? So these anti-patterns come from that experience. So, anti-pattern number one, the giant backing bean. So, how many people, and just for those of you who don't know, a backing bean in JSF is essentially just a controller. It's a page controller, right? So it's the class that basically handles all the UI functionality for a particular page, usually. So how many people have backing beans that have several hundred or thousands of lines of code? Okay, so that's a few of you. All right, so if your backing bean is like 2,000 lines of code, then you have a problem, okay? Because essentially you're talking about a controller for a single page. Why does it need 2,000 lines of code, okay? Often what will happen is it has sometimes unnecessary comments, one of my pet peeves, right? If you have a line of code that grabs a service object, you don't have to write a comment that says grabbing a service object. It's not very useful, right? If you have a method called, get list of widgets, you don't have to have a comment that says this method gets a list of widgets, okay? So that's one of the reasons, but there's more important problems, right? So often these days you have very complicated views that use Ajax, right? So instead of having a whole bunch of different pages, you have maybe a smaller number of pages, but on any given page, there's a lot of different things that can happen. And so in order to handle all of those interactions, often your view, your backing bean gets very large, okay? So that does happen. But there's not a whole lot you can do about that. You may end up separating some logic out into different classes, okay? But if your backing bean, if the view has to have that much stuff going on, and there's really no logical way to separate it, you may be stuck, okay? But you may be able to separate some functionality into different backing beans. There's no particular rule that says any backing bean can only apply to one page. You can have more than one. So if you have a very complicated page, you may have a couple different backing beans working together. That's a possibility, okay? Another thing that happens is business logic in backing beans, right? So if you have an application that doesn't have a lot of layering, you may have a lot of business logic in your backing beans, and that may be contributing to a very large backing bean, okay? One very simple rule of thumb is that if you look at a method, and often it'll be an action method, one which is executed by a button or something, maybe it's save page or launch process or something, okay? If that method is like 5 or 6 pages of code, bad sign, right? Because that probably means you're doing business logic, maybe you're opening up database connections and things like that. And when you do that a lot in your backing beans, you end up making them very large and complicated, right? So if you see that, it often helps to sort of factor that out into another layer, maybe a facade, maybe a service layer or something like that, okay? And one of the benefits of that is that, if you do that enough, you find patterns, right? You may find that 4 or 5 backing beans use the same sort of business logic code, and then if you have them in another layer, you can just use it once as opposed to repeating it in several places. The same thing goes with data access logic, right? So if you find you're doing a lot of database stuff in your backing beans, then it's probably time to move it into a different layer. Now it's fine in simple cases, right? If you have a very simple backing bean, you don't have any complicated logic, you may inject a persistence manager and just do stuff there. That's fine if it's simple, but if it gets to be complicated, you definitely should put it into a different layer, okay? So I can't stress enough how frustrating this is for new people on projects, right? So how many of you have started a project and you look at a class and find out it's like 3,000 lines of code? Anybody? Is it just me? Okay. All right, so it's very hard to figure out what's going on in a class that large, okay? So in this case, of course, you can refactor. That would be the number one thing to do. You can create multiple backing beans, as I mentioned before. So you may have multiple backing beans working together in the same view. Move code to separate layers. Also, utility classes, that's an important thing, right? So there's no rule that says you can't have static utility classes or maybe application scope utility classes to take some of the logic that may be in your backing beans. That's something to consider as well. And of course, other scoped objects. So maybe you look around in your backing bean code and you find, well, really, this logic should be in a session scoped object, or maybe it should be in a conversation scoped object, or maybe it should be in an application scoped object, okay? But the idea is not to put too much stuff in your backing beans. Okay, so does anyone see anything wrong with this picture? Anybody? Any clues? This looks perfectly fine? Yes?
When you say entities, is the systems entity?
Yeah, yeah.
A widget should inherit from an entity.
What inherits which one?
The widget, I don't think it should inherit from the base entity if it's a system instance.
Okay. All right, that's sort of along the lines of what I'm getting at. So this is what I call the backing bean subclass's domain object, antipattern. And I will say none of these are official antipattern names. They all come from my head, so don't look them up on the web and expect to find like a whole bunch of books on with these topics or anything. All right, so in this scenario, what we have, like he said, we have a widget with subclass as the base entity, right? That's not necessarily the problem if you consider that a widget is a domain object, right? Widget might subclass some sort of base object, right? The problem really is that the backing bean is subclassing widget, okay? Because, from an OO perspective, widget might be an entity, right? But a widget backing bean is not really a widget. A widget backing bean is a controller for a page, okay? How many people have seen this before? I'm just curious. Ah, that's kind of cool. All right. So I've definitely seen this one before. So of course this violates separation of concerns and basic OO principles, right? Because we have, a backing bean which is also a domain object but shouldn't be. So really you should have something more like this, where a widget backing bean just uses the widget and the widget subclass is the domain object, okay? Okay, so does anyone see a problem with this? Anybody? This one's a little more subtle. So this is what I call the flat backing bean hierarchy, okay? So just because your backing beans are controllers doesn't mean that you can't actually use inheritance, right? There's no rule that says a backing bean can't have a superclass, okay? So in larger applications, and actually I say most applications, you probably want to do this. You probably want to have at least one backing bean superclass, because I'm betting that there is some ability or some need to reuse some sort of functionality across different backing beans, right? So you probably should end up with something a little bit more like this. So we have a base abstract backing bean. This has whatever utility methods that all the backing beans need. Often this will have methods for grabbing references to different service objects or other sort of application level objects that all the backing beans need, okay? Sometimes in larger systems you'll find that there's a base backing bean for each subsystem, okay? That may have additional functionality for that subsystem. And then of course you may want to do other subclassing. So here we have a widget editor, and the strange widget editor is just a page which is very similar but has some additional functionality. So we just subclass the widget editor backing bean, okay? So keep this in mind when you're developing your backing beans, that it's okay to have a superclass, and I actually recommend to have at least one base backing bean class, okay? Okay. Anyone see anything wrong with this code? I'm going to do this throughout the session, though, so feel free to raise your hand at any point in time. Yes?
I don't know. I know that you can do it, but I'll put the validator elsewhere so I can reuse it instead of just putting it in the same. That's a method from a backing bean validate name. Does not implement the validator interface.
Okay. So he's saying, he probably would write a separate validator class so he can reuse it. So that's definitely something you can do. Any other thoughts?
The faces context in arguments, normally it's accessible anywhere in your code, so you don't have to place it on the argument of the function.
Okay, so he's saying you don't have to pass the argument. And actually, this is the standard validator method signature, so this is the default signature, so it's going to pass it anyways. So, I mean, technically, you could call it without the signature in JSF too, but that's what the signature is like, so you have a handle to it. There's another answer over there?
Yeah, the name, the idea of the message, the component in the message where you don't use the server objects.
That's it. Okay. So he's talking about this, right? So this is the problem, okay? There's actually two problems here, but this is the main one. So we are adding the new widget here, okay? Or we're adding a message here. And there's not really good reason to do that in this case. So this is what I call the magic string dependencies a problem, okay? This is a very common problem that I see where there are strings, and the most common one are component IDs, which are used throughout the code. So whenever they change, you have to change lots of different artifacts, okay? So the problem with this is this assumes that you know about a component called called name, right? Inside of a form called new widget form, okay? So let's say, developer Susan shows up one day and she, starts working with the code. She's looking at the XHTML page or the JSP page, whatever. And she says, new widget form is a bad name. Let me change it to form, okay? All of a sudden, this doesn't work. This breaks, okay? Now, maybe you have strong conventions, naming conventions to keep it, so that Susan would know that. But you're not always going to know that, okay? That may not always happen. The other problem is that, let's say that during the course of a design meeting, someone says, well, we like it like this, but really we want to put the whole thing inside of a data table, okay? And we want to repeat the form, not the form, but the name over and over again or something, okay? So a data table is what's called a naming container, which means that the client ID is going to have the prefix, it's going to have the data table ID in front of it, okay? Which means this ID will change again. So if you ever put a component inside of a data table or form or a tab component with some component libraries, those are naming containers, which means the whole client ID of the component will change, okay? So this basically means the code is more brittle, right? Because you have a magic string, and the magic string does change in JSF. Not always, but it can, okay? So the proper way to do it would be something more like this, okay? As he mentioned, the sender, the component is passed in. There's no reason to look it up or to hard code the ID. We have a reference to the component that's being validated, the one that has the issue, right? So because of that, we don't even have to use the ID specifically. The other thing is that in a validator, when there's a problem, you're actually supposed to throw a validator exception, okay? And when you do that, it's smart enough to figure out what component to associate it with anyways, okay? So keep that in mind. If you're writing a validator, if it fails, validation fails, you throw a validator exception. The same way that if conversion fails in a converter, you throw a converter exception, okay? And also, there's no need to hard code the ID, okay? So here's another example of the same problem. So we have a method called delete widget, which is presumably called in a data table or something, okay? And this is actually based on real code that I've seen. Here, we look at the ID. We get the client ID of the component, right? And we look at the ID and we do some string manipulation to figure out what row it is, right? And from that, we can then call another method which just takes a number as a parameter. Okay. So again, this is using the ID of the component to do something fairly complicated to determine what row is being edited in a data table, right? Now, there's a couple problems here. Number one, Again, the ID can change, right? If the ID changes, the code breaks. And that's actually what happened in this project. That's how we found this code. We upgraded to a new component library, or a new version. I think this was Rich Faces or something. And lo and behold, this code broke, right? But the other problem here, in this particular case, there are much better ways to get the row ID, right? You don't have to parse the ID of the component, okay? So this, of course, is the problem, is this code here. And in general, if you want the ID of, or the row of an object in a data table, there's a couple different things you can do. In JSF 1.2 and also in JSF 2, you could use the fSetProperty action listener. How many people have used this element before? Okay, so a few of you. Okay, and what this does is when this button gets pressed, this property will be set on the backing bean. So when your delete method gets called, then it'll know what the current widget is. Okay, so that's a pretty handy thing to do. And another thing you can do in JSF2 is you can just pass in the widget. So JSF2 allows you to pass in parameters to methods and use arbitrary method, basically any sort of method signature you want, right? So here, since the data table has, every row is called a widget, we can just pass in widget as a parameter to the delete method, okay? Then we don't have to worry about the row index or anything at all, okay? All right, so there are situations where you really do need a reference to a component, though, right? And that's a lot of what the magic string problem is for. So one of the things you can do is, of course, use value or component bindings, right? So value binding is pretty much what we're used to, where you bind a component's value to some property, right? So this is what we call a value expression or a value binding. But then there's also component bindings where you bind the component instance to your backing bean, right? And that allows you to have a reference to the component in your backing bean. So that is the much preferred way to get a handle to a component, as opposed to hard-coding the ID and then looking for the component, using one of the methods on the component tree, okay? Of course, if your component is being handled inside of an event listener, like an action event or an action listener event or a validator, you of course have a reference to the component itself, so then you can just use that. There's no need to hard-code the ID in that case either. Okay. Any questions so far? Okay, good. All right, so this is another one, which is maybe a little bit less obvious. This is the unnecessary faces context lookups antipattern. So basically, if you call faces context.getCurrentInstance multiple times in a method, it's not a good thing. Can anyone tell me why? Anyone know why? Okay. Well, first of all, let me say, for those of you who aren't familiar, faces context is a very handy object that gives you access to all the JSF objects, essentially. So if you ever need a reference to it and you don't have it, you can call faces context.getCurrentInstance and then get a reference of the object, okay? The only problem with calling it all the time is that the faces context object is a thread local variable. Okay, and the thread locals are a Java JVM feature that allow you to associate an object with a particular thread. Okay, and that makes sense in a servlet environment because each request coming in is handled in a separate thread. Okay, the problem is when you retrieve a thread local variable, it's expensive. It takes time. Okay, so you'll find if you look inside of any JSF implementation, whether it's MyFaces or Mahara, they actually go through some effort to not call the faces context.getCurrentInstance all the time, okay? So in your own code, you want to try and be careful about calling it repeatedly, all right? So if you have a method and you need to work with the faces context, basically just store it in a variable, right? don't call the method to retrieve it multiple times in the same method. Okay, and if you can, pass it around. Okay, if you know you have to call another method, and that method expects to be called, but from somewhere else, you can pass it the faces context. Okay, so that'll definitely help out with performance a little bit if you find that your application has lots and lots of extra calls to the getCurrentInstance method. Okay, so this is one of my big pet peeves. Does anyone see anything wrong with this code? Okay, nobody sees anything wrong at all. All right, so that's a good one. That's not the main problem, but that is a problem indeed. So he said they're all session scoped beans, which is true. Which is okay. So he's saying widget editor bean should probably have its own scope, which is true. Which is true. Yes. Okay. So he's saying, there probably shouldn't be uses between these two classes, right? Because maybe strange editor bean should subclass from widget editor bean, and that's more along the lines of what I'm thinking here. So this is what I call the interdependent backing beans anti-pattern. Okay. So a backing bean is essentially a controller, right? And usually a controller's interface is directly to the page, right? Or the user, however it may be, right? The controller's interface is not really geared towards other controllers, okay? And that's basically the problem with the interdependent backing bean anti-pattern. So here, the main issue is that we have 3 different backing beans that all use each other, right? This one uses that one, this one uses that one, okay? And this one uses this one, okay? So the interface for these classes should be to the page, not to each other. Okay. So the best way to handle this is essentially to factor out behavior to other layers or helper objects, right? So of course, one way is to use subclassing, right? So if you have common functionality, you can of course have a subclass. Okay. Another thing you can do is if two of the same objects need to reference some or need some common functionality, put it in either a utility class with a static method or another object in different scopes. Maybe that object lives in session scope, maybe it lives in application scope or conversation scope, who knows, okay? But the idea is to essentially make sure that it's in, basically the common logic is factored out, okay? And the reason this is a problem is because it sort of violates the contract, right? The controller is supposed to deal with the view, okay? So then if the controller's interface also has to be to several other objects, several other backing beans, it gets very complicated in terms of seeing what happens. So something I often see is that, or I have seen before, is that there's an action method in one backing bean, right? So it presumably provides some functionality for a page, right? And then it calls an action method in another backing bean, okay? But I thought an action method's job was to service the page, right? So when I see an action method, I don't think it's going to be called by another backing bean, okay? And then imagine that the second backing bean then calls another action method, another backing bean. Suddenly it gets very confusing in terms of determining what the actual functionality is for that button that the user pressed, okay? Now, if you factor that out into maybe some sort of utility class, it becomes a lot easier to understand, okay? So, of course, when you factor out the objects, you can, of course, inject the dependency, right? So you can then inject your application scoped object or your session scoped object that has that common functionality, okay? So what we're looking for is something a little bit more like this. So here, we have the strange widget editor bean, okay? and this really should be a subclass, right? So it does subclass the widget editor bean. Okay. They use widget util, which has some of the little static utility methods for working with widgets. Okay. And the widget listing bean uses the security manager, which is some sort of application scoped object which just has security methods. Okay. And also the login bean uses that as well. Okay. So we've now factored out the functionality that was all in the login bean to be in the security manager. And we factored out the common functionality for the widget objects into the widget util class. Okay. So this way, things are a lot easier to maintain, and the backing beans still have that strong contract so that they're supposed to talk directly to the views. Okay. Now, one of the things you may have noticed here is that the scopes have changed, right? So in this other slide, we had a session scope, right? All these beans were in session scope. And that's generally an anti-pattern itself, which I think I may have made a separate pattern, I'm not sure. But the reason they're like this is because often when you have this sort of strategy of interdependent backing beans, you sort of end up putting everything in session scope because you need to reference all these other backing beans, right? So you sort of mess up your scope management. You don't have as much control. Because if you put, let's say, widget listing bean in request scope, well, then every time you did something with widget editor, you'd be creating new widget listing beans. You know, it just doesn't really work too well. So you sort of end up putting things in session scope. So if you decouple things, you can then pick the proper scope for the object. So here we have strange widget editor bean is in view scope, which is in JSF2. Login bean is just in request scope, and so is widget listing bean. Okay, widget util is a static utility class, so it's not in a particular scope. Okay, so now we have a lot more control over the scoping of our beans as well. Okay. Okay, so here is another one. This is what I call the giant view anti-pattern. And this happens more on the page side of things, right? So basically the problem is that similar markup is repeated in every page, okay? So, you know, you have your JSP or a facelet page, and they have lots of the same markup over and over again. And I see this happen sometimes in cases where you have a designer who gave the code to developers, and the developers really didn't try and sort of clean up the code. They just took it as is, essentially. Okay. So in these situations, there's no templating or reuse, right? So Facelets has very powerful templating, so you should definitely use it. If you find that you have, you know, the banner, the header, and the footer repeated on every single page, it's probably time to factor it out into a Facelet template, okay? Or at the very least, if you're stuck with JSP, use a JSP include, okay? All right, another thing which you can do is break up pages into smaller fragments, okay? So sometimes you have views which are so large that even your IDE struggles. How many people have that page where you open it and you wait like 5 minutes for your IDE to parse the page? Anyone have that problem? Okay. All right, so that may be a sign that you might want to factor things out a bit, okay? So remember, you can just factor it out into smaller pieces and just use includes, right? It's a very simple thing to do. Or if you have an opportunity for reuse, of course, you can use templating as well, okay? Another thing that you can do is use composite components, right? So how many people have developed a JSF2 composite component? Okay, so decent number of you. So composite components are probably one of the best JSF2 features, and they essentially allow you to take a fragment of markup and then reuse it in different pages, and they allow you to have that fragment have properties and methods and things like that as well, like a real component. Okay, if you've worked with Facelets, it's sort of like a Facelet composition but better. Okay, so that's another way you can break out functionality as well. Okay. So if you have a giant view, if you find yourself waiting to load a page, then you probably need to think about ways to factor it out, or clean it up, or move it into templates. Okay, so here's an example of a fairly typical sort of page, right? So you have your form, and your form has a panel. Panel has some input controls on it. You have another panel, has some input controls on it, and then you have a panel with a couple buttons, right? It's actually a pretty simple form, right? So this is something you may have in your application. You probably have lots of pages with something like this on it, right? With just some input controls on a form. However, often what happens is, the UI that your users want is much more complicated. So you really end up with something a little bit more like this, okay? So here, you have your view. Your view has a panel in it. It has a tab panel. Has like 4, 5, 6, 7, 8, 9, 10 tabs, however many tabs. And each tab has all of these components in it. It has, the form with, a whole bunch of input controls, et cetera, okay? How many people have had or have an application sort of like this? Okay. All right, so it's fairly common. But it's also something you need to be careful about, okay? And this is what I call the bloated component tree problem, okay? So the idea is that, your user has pretty high expectations. They want a fairly complicated user interface, right? And since we're living in the days of AJAX, you put all the stuff on one page, right? Because what you want the user to be able to do is they hit on one tab and, they get an instant, experience by just hiding or showing that individual tab, okay? In the old days, that tab might load a whole new page, so it'd be a whole different ball game, right? Now, I'm not saying this is necessarily wrong in all cases, but I'm saying it's something that you should keep an eye on, because a bloated component tree consumes lots of memory, right? So JSF, for better or worse, is a stateful component framework. So this means that every component that you put on a page has a server-side footprint, right? It has an object on the server which has some state, okay? So if you have a page like this, and in a more realistic application, this page would probably be at least 2 or 3 times as large, this part of the page, the actual form, right? This is going to take up a lot of memory, right? And that memory belongs to that individual user because, each page in JSF is basically stateful and associated with a particular user, okay? So, you have thousands of users online. They each have this huge page. It's going to take up some RAM, okay? So it's something to keep in mind. Another issue is that this may render a very large page, okay? And by that, what I mean is that the actual markup that's being sent to the web browser could be very large, okay? So depending on how you design your page, when you have something like this, the browser may be sending all of these tabs, the server may be sending all of these tabs to the web browser even though they're not all being seen at the same time, right? So a user can only see one tab at the same time, so why does the user need to be sent every single other tab, right? And of course, what that means is that you have more network bandwidth being used and also slower rendering times in the browser, okay? So this can affect performance as well. Okay, and of course, this all means the page might be slower. So this is something important, hence the blinking effect. All right, so the rendered attribute does not affect the size of the component tree. All right, so every JSF component has the rendered attribute, right? And the rendered attribute means just that. Is it rendered? Does not mean that the component tree is smaller if it's not rendered. But it does mean that it won't be sent to the browser, right? So if all those tabs that we showed previously had rendered equals false or something, they would not be sent to the browser, which would decrease the browser rendering time and decrease the network bandwidth, which is good, right? However, it does not mean the component tree is smaller, okay? So that means that the overall footprint of the page in memory is going to be roughly the same, but the user experience is still going to be better because they won't be sent like 6 tabs that they don't need, okay? So just keep that in mind. Rendered attribute does not shrink the size of the component tree. So when you are building pages, these are some of the things you can think about in order to keep the size of your page manageable. First one is Ajax really required? Okay, so everybody likes to use Ajax because it's hip. We've been taught to think that's how all pages should be made now, right? But I encourage you to think about it when you're developing a page. Do you really need to have Ajax everywhere, right? Because the more Ajax you use on the page, often the larger the component tree is, right? Because you're hiding and showing lots of things, right? Another thing is that you have now, in some cases, you're beholden to the network, right? So the user does something, and now they have to wait for the Ajax request to occur, right? Now, depending on your whole deal, whether you're on a VPN or the internet or whatever, that server response time may or may not be fast, so you need to keep that in the back of your head as you're developing things, okay? And now, there's some more I want to say on Ajax when we get to the end. I don't have too many slides on it, but I have some other thoughts as well. So just keep that in mind. So if Ajax is not really required for all of those tabs, then maybe you can make some of them like a full page refresh or something. Or maybe it goes to another page. Maybe there's another layout approach you can take, okay? Another thing you might want to do is consider transient markup, okay? So in JSF 2 specifically, and also facelets in general, basically there's a notion of what's sort of called transient markup, and then there's actually the component tree, okay? So transient markup, which is like things like any HTML markup that's span, div, whatever, that's not actually a JSF component, that actually is considered transient, and it's actually cached. There's only one version of it in memory, okay? It's actually part of the facelet. Okay, so what happens is basically the facelet template stuff gets merged with the actual component tree when it's rendered. Okay, so essentially, the more of your content that is actually transient, which is just markup and not components, the smaller the footprint of the component tree. Okay. So that's something to consider. So, I generally like to use panel groups and things like that in my page, but in some cases it's really not necessary because I'm not hiding and showing the panel dynamically. I don't need any of the JSF features on the panel, so I can just put a div there because the panel renders either a span or a div. Okay, so keep that in mind. Some components have, or some component libraries have dynamic loading features, okay? So for instance, in prime faces, the tab view component has a dynamic property that will dynamically render a tab when it needs to be displayed, okay? So in that way, I don't have to worry about setting rendered equals false or anything like that. Basically, I just turn on the dynamic property, and then whatever tab I go to is then sent to the browser. So that helps with the size of the page being sent to the browser. It doesn't help with the component tree on the server. Okay, so take a look at your component suite because it may have the ability to do some optimizations for the size of the component tree, or at the very least, the markup that's sent to the client. Okay. Another thing which helps, if your view is large, or even if it's not, is to use a scope other than session, right? So how many people have an application that has all the pages in session scope? All right, so at least one of you does. All right. So don't do that if you can. If you can't avoid it, I recommend against that. And so if you do have a large component tree, if you basically try to basically get rid of it as soon as you can, it makes sense. And another way which you can do this is, a way that you can do this is to adjust one of the actual web.xml settings for JSF. So both Mahara and MyFaces, and I think this is actually a standard parameter if I remember correctly. You can control, actually, maybe it's not. Anyways, there's a context parameter that lets you control whether or not, or lets you control how many views are stored in the session, okay? So usually when you go through the application and you're going from page to page, let's say you log in, you go through 5 pages, JSF will keep all 5 pages in memory, all the actual component trees, so that when you go back to a previous page, it's there, it doesn't have to reload it and everything, okay? So let's say you have some very heavy AJAX pages that have lots of components and everything and take up lots of memory. Maybe you don't need to keep all 10 or 15 of them in memory for each user. Okay, that setting by default is usually 15 or 20. Maybe it should be 5 or 10. Okay, so if you change it, what will happen is JSF won't keep as many views in memory for a particular user. Okay, so that's something to consider. And usually in heavy AJAX applications, the user spends more time on a fewer number of pages anyways. Okay. Another thing that you can do is use the CIF tag. Okay, so this is a feature from JSTL that's implemented in Facelets. And what CIF does is it actually controls the creation of the component tree. So whereas render just decides whether or not the component is displayed to the browser, CIF actually decides whether or not the markup inside of it is added to the component tree. So in some cases, you can use CIF to decide whether or not a particular subtree is even going to be there. And that will help not only with the client side, but will also help with the server side footprint of the component tree. Okay? Now, the caveat is CIF is a little tricky, so you just need to make sure you understand it before you use it. Don't start using it everywhere. Okay? Generally, if you want to hide or show something, you use a rendered attribute. CIF is better if you really are trying to have more control over the component tree. Okay?
Can I ask a question?
Sure.
I've used before CIF in some pages, and because of execution time and rendering time, when you use view scope manage bins, usually you get some weird behavior on the pages. So
This is why I say you should use it sparingly.
I'm not sure how the page is going to be rendered.
Yeah, I'd have to know more about your particular use case. But if you didn't hear him, he said he's used it sometimes on view scope pages, and he's had some issues with it not working properly. So it is a little bit of a tricky component to use. And I haven't really used it with view scope recently, so I don't know if there are particular issues with view scope. I'm not sure though. But I'd have to know more about your use case to know exactly what the problem is. Okay. And of course, you can split into separate views, right? So sometimes that may be an option if you think there's something that someone doesn't see very often. Maybe you display a completely different page in a pop-up. Who knows? Okay. Okay. So does anyone see a problem with this code? Yeah. Either one of you is fine.
You should not instantiate variables in the getters and the setters because they get called multiple times in the GSF lifecycle.
Okay, so he's saying you should not instantiate variables in your getters and setters because they get called a whole bunch of times in the JSF lifecycle. This is very true. They do get called all the time. So you definitely want to avoid creating expensive variables, creating database connections, doing expensive lookups. Any of that in your getter method is always a bad idea. So that's basically the idea. In this example, widget provider is presumably some sort of data access object or service or something, right? So it's probably kind of an expensive thing, all right? But there's another thing going on here besides the fact that it's being instantiated, okay? So this is a similar example, okay? And it has the same problem, right? We're doing a lookup here. The lookup presumably is a little expensive, right? We're doing it in the getter, and we're grabbing this user provider object. Okay, so here we're using it the expression language, so we're getting it from whatever scope it's in, right? So this is actually a little bit better in some ways, because here at least we know it's a singleton, right? It's probably an application scoped object as opposed to being a variable that's just instantiated. Okay, so whereas in this example we might be instantiating this provider, hundreds and hundreds of times when it's essentially a singleton, right? Here at least we're grabbing it from application scope or something, presumably. Okay, but yes.
I was going to say you're calling the faces context and recurring consistent result.
Yep, that's another problem too. So of course, as I said before, you don't want to call this method all the time. And here we're calling it inside of the getter, so it's really going to be slowing things down. Okay. But the other thing, which we're seeing here, is lack of dependency injection, right? So we've got an application scoped object, which we need to reference, and we're either creating it using the new constructor, or we're grabbing it every single time using the expression language, right? So that's really where dependency injection is very handy.